Hello and welcome to Instructor Allison Online Tutorials. In this video, we are going to discuss electric field. So the concept of electric field can never be overemphasized. If you consider field itself, we are talking about an empty space. All right. So if I have a charge situated in a space, an empty space, I wouldn't know the behavior of this charge except I have another charge in the same space, and then depending on how close this charge is to this first charge, that will tell me the behavior of this charge here. If this charge are to be positive, then you will have to experience a repulsive force. But if it is a negative charge here and a positive charge, then we will experience the force of attraction between these two charges. And then this force we are talking about is not something we see or we can see with our aided eyes, but we can experience it or we can feel it by using electric lines of flux. Electric lines of flux that runs from the positive and terminates at the negative. All right. So in general, electric field can be defined as the region around a space where electric force can be felt or experienced. All right. And then we can use different formation of charges when charges are placed. Of course, charges always flows from the positive and terminates at the negative, which is why you see the indication of this arrow, and this is showing that the charges are coming from the positive. That is the indication of the arrow, and these charges are entering the negative part, or entering the negative charge. Look at these indications also. Is also demonstrating that the charges are flowing from the positive and they are entering the negative. And this is what we call unlike charge. And this is what we call unlike charge. We have another case where we have two charges also. It could be positive and positive. And what do we experience, or what force do we feel? Is it the force of attraction or the force of repulsion when we have two charges having the same poles or the same sign? Like in this case, we're having positive, positive. You observe that at this point, all these charges, the two charges will be repelling from each other. What do we mean by repulsion or repelling? It means they will be moving away from each other. That's what it simply means. Whether they are positive, positive, or they are negative, negative, the effect is that they are going to be separated. And at this point, you experience what we call field, which is a region where you can feel this force, the force between these two charges. You can feel it, you can experience it, but you can see the forces. So that is the concept of electric field. So this we call like charges. Like charges. You can represent them in negative, negative, or positive, positive. The same way we did on like charges, positive and negative. All right? So that is the basic concept of electric field. So in order for us to understand the relationship between the positive and the negative charge, we will have to introduce a concept called Coulomb's law. And Charles Coulomb propounded a law, and he named the law after his name, which is Coulomb's. And what does the law have? Coulomb's law states that the force of attraction or repulsion between two charges, Q1 or Q2, is directly proportional to the product of the charges and inversely proportional to the square of the distances apart. What does that mean mathematically? Mathematically, the law states that the force of attraction or repulsion, you can call this force an electrostatic force, or you can call it the Coulombic force. Notice that when we talk about the concept of centripetal force, we have F subscript C. But in this case, I'm talking about Coulombic force, or we can do away with it. Or some cases, we can use electrostatic force, which is the same thing as Coulombic force. Or we can leave it like that. This force is the force of attraction or repulsion between two charges. You can term the charges Q1 or Q2. Another expression, you can still represent it with Q and small letter q. You can as well represent these two charges as Q1 or Q2, as I said earlier. It could be Q subscript A and Q subscript B. But what we are concerned about, these charges are two. We are talking about the product of charges and inversely proportional to the inversely proportional to the square of the distance apart that separate the two charges. So, in a nutshell, Coulomb's law states that the force of attraction or repulsion between two charges is directly proportional. This is a sign of direct proportionality. Is directly proportional to the product of the charges. And we can term this as equation 1. This same force is inversely proportional to the square of the distances apart. And this could be our equation 2. So this similar force, you can take one of them and one of these. If you multiply Q1, Q2 by 1 over r squared, then you have the result Q1, Q2 all over r squared. This could be our equation 3. So in order to further work on this expression, we can change the sign of proportionality, and when we change that, we introduce a constant k. So at this point, you can say that F is equal to k Q1 Q2 all over r squared, where these Q1 Q2 are the charges that separate or that multiplies themselves, or the charge of attraction or repulsion. This is the force of attraction or repulsion, and this arrow is the square of the distance. Arrow is the distance itself. K is a constant of proportionality which has a value as 1 all over 4 pi epsilon naught. And what is this epsilon? Epsilon means the permittivity of a free space. And the permittivity of a free space, permittivity of a free space, that's what the symbol epsilon stands for. And it has a constant value as 8.85 times 10 to the power of minus 12 force per meter. That is the constant value of this epsilon, which is the permittivity of a free space. Again, when you work on this mathematics, pi is 22 over 7, which is 3.142. 4 is constant, 1 is constant. By the time we multiply 4 by pi by epsilon naught, which has this value, divide 1 by the result, you have an approximate value of k, to be 9.0 times 10 to the power of 9 force per meter. And this is the approximate value of k. So in this case, this expression can still be manipulated. We can still place this as F equal to, hence we have this k to be 1 over 4 pi epsilon naught, and it multiplies by Q1 Q2 over r squared. The result of this will be when 1 multiplies by Q1 Q2, you have Q1 Q2 all over, the whole of this multiplies 4 pi epsilon naught r squared. This is another expression for F. So you can see that these things could be expressed in different ways. So that is what Coulomb's has, and that is the expression for Coulomb's law. Take note of this, it's very important, especially for those of you who are preparing for A-level exams, pre-degree exams, WAEC exams, JAM exams. This will be useful. You should be able to understand how these are connected. Okay, again, there's another concept that we will need to introduce so that we can be able to see how we can manipulate this expression to fit in the concept I want to introduce. And what is this concept? It is electric field intensity. Electric field intensity, by definition, is the ratio of force per unit charge. Electric field intensity is the ratio of force per unit charge. Electric field intensity. So we can represent this by E, and the definition to this is the ratio of charge, the ratio of force per unit charge. All right. So, but then a problem might come and you'll be asked to calculate for electric field intensity, and distance will be given in that problem. Force might not be there. So how will you be able to fix in such kind of problem? This is why it is important we introduce the relationship between the first equation we worked on, this equation, and this. And what is the relationship between this? Sorry. The relationship is this. If you want to further expand this expression, recall that from this expression, force is given as kq1 q2 all over r squared. So at this point, what we need to do is this. We substitute this force, the value of this force, into this particular force we're having on the equation star. So that is to say, this E will be equal to, in place of this force, I will represent it with this expression. The expression here, which is kq1 q2 all over r squared divided by this particular q. Note that this q is equal to q1 equal to q2. They are the same. That is to say, this q can easily cancel any of them. I only use q1 and q2 to separate the two charges. So I can easily use qa, q subscript a, or q subscript b. I can use capital letter Q and small letter q. You can see that this can easily cancel any of them. So that is why I bring in this. By induction, Q is equal to Q1 is equal to Q2. So at this point, this Q can easily cancel out with any of these Qs. So therefore, we have E to be equal to, which is the electric field intensity, will be equal to KQ all over R squared. So this is another expression, and this expression is for electric field intensity. I can also work on this expression in such a way that we can position it in the form of substituting this expression. If I substitute this value of K into this expression, this electric field intensity can further be written as E equal to 1 all over 4 pi epsilon naught multiplied by Q all over R squared. So at that point, what we need to do is to say that E will be equal to, this multiplies by this, we have Q all over, if this multiplies, we have 4 pi epsilon naught R squared. This is another expression for electric field intensity. So thank you very much for enjoying this video. Make sure you like, subscribe if you understand the concept of electric field intensity, electric field, and Coulomb's law. Peace.